I want to do another video on Delta Lake. I know I recently did a very high-level conceptual, kind of like what is Delta Lake, and it was very high level. We didn't really jump into it that much. I want to do a very quick intro into Delta Lake. What is Delta Lake? Delta Lake, again, at a very high level, is an open source project. It's gotten popular because of Databricks, and it is a semantic layer, storage layer, that kind of gives you the feel of a normal database. It gives you kind of like the create, update, delete, and ACID transactions in a big data context. And it is definitely an open source project, but made popular by Databricks. Therefore, many people use it with Spark, even though that is not a requirement. For example, there is the Delta RS project that we can look at. It's a native library written in Rust that can interact with Delta Lake. And I actually have some of the projects I've worked on myself that we can look code at that I am interacting with Delta Lake without using Spark, for example. But if we want to just talk about Delta Lake at a high level, what would that look like? Let's just open a notebook here in the community session. So Databricks has a community edition. It's free to anybody. I highly suggest you go ahead and use that. Just going to create a new cluster in Delta Lake. In Databricks, we're going to create this new cluster, and then let's go ahead back to my workspace and just pick a notebook. Attach it to new cluster. It's going to start that cluster, and then we are going to do some stuff with Delta Lake. What is Delta Lake at a high level? Delta Lake is really just Parquet files. For example, I recently was working on a personal project of mine just for fun and for learning. It is a tool built around flat files, and yesterday I was working on it and added some ability to write to a Delta Lake table from a CSV file, for example. And here is an example of the actual Delta table that this code wrote. It took a CSV file, the sample CSV, and wrote it to a Delta Lake. What is a Delta Lake? A Delta Lake is actually just Parquet files stored somewhere with a Delta log, which is some JSON files that kind of tell us which files are valid, what's been updated, or what's been deleted. So that's honestly all a Delta table is. It's Parquet files with some logic on top of it. Obviously that's simplifying it, but that's really what it is. What makes Delta Lake special? Well, if you've never used it before, we're going to interact with it through the Databricks notebook, as we are going to do something that you would be used to in any other database tool, but not typically with file storage, right? Back in the day, you had a bunch of Parquet files stored in a data lake, and you updated or deleted something. That was really hard because you'd probably have to rewrite the entire data set. Unlike Delta Lake with the Parquet files and then a JSON file tracking what happens in the background, it just makes the semantics really easy to manage. So for example, we could say create table trips. Very similar, ANSI SQL. We could say we want an ID that is big int and not null, and not null. That is not null. It may be the name of the trip, which is a string, and how far, which is maybe like an int. It's going to hold how miles, something like that, right? And that is really a Delta Lake. We can interact with that Delta table even though there's nothing in it. We can interact with it. We can say select star from trips once the other query is finished running. I remember we're doing this from Spark because Spark has the Delta API integrated into it very nicely, which is great. But it's not totally necessary anymore. You can have other tools like Python and Rust interact with Delta Lakes without Spark. So it's running our command and taking forever because it's a free version, so everything's slow, nice and slow. And our cluster is not that big. How big is it? 15 gigabyte cluster, 2 cores. Oh, there it goes. It's finally running our command. can see it computing the snapshot for version 0 of our table. That's those JSON files we looked at. And now that it's done, we could say select from trips. And it's not going to give us anything because we don't have any data. There is no data in there. But if we wanted to, we could say insert into trips. And that is going to insert data into our Delta table, which is actually Parquet files stored on a file system. Now it inserted those records. We should be able to run this and see data. And what's amazing about this technology is we're not talking about MySQL or Postgres. These are Parquet files stored somewhere. That's pretty cool. And what makes Delta Lake awesome is because it gives you these powerful semantics like this. Update table trips, set name equal to road trip, where ID equals 123. And you can see it's running an update statement on, again, Parquet files. And if we run our select statement that I overwrote, will the name have changed? Yes, it will. Update. That's a powerful statement. It seems very easy and kind of almost dumb in a sense. But what's amazing about this is it's scalable. It's used with things like Spark with hundreds of terabytes of data. And it works seamlessly and gives you the feeling of a data warehouse that you would have had on SQL Server, except you're using scalable storage in the back end. You can connect Delta Lake to tools like Trino or Presto or Spark or anything else, those big data tools, and you can interact. You can model data a certain way. It makes modeling data and storing data very easy. It basically unlocks a ton of business value. What do you need to know? What else? Well, there's lots to know. We can run optimize commands because these are files in the back end, right? So we'd want to run optimize them. It makes, compacting files better. You can run vacuum statements to delete old files. So it does have some different concepts. Another concept we didn't have here, but there is a concept called partitions. So we have all these files being stored in the background. Sometimes you want to break those files up into different groupings. A lot of times it can be time series based. That way when querying these files, it's a lot quicker, because obviously when you're storing files in the back end, you have hundreds of thousands of files or millions. You need to be able to efficiently run things like this, or to run update statements. And the partitions just group those files in different places to make it easy to do those things. And then last but not least, I'm going to go back to talking about this again. Delta Lake is not only used with Spark, but there's things like Rust where you can interact directly with Delta Lake. It comes with Python bindings, as well as I've obviously shown you Rust here where you can interact with it. I wrote some code recently here where I'm actually reading a CSV file and creating a Delta table from scratch, and basically converting those CSV records and pushing them through a JSON writer into a Delta table. So you don't necessarily need Spark to do that. And all that to say, what is so special about Delta Lake? I talked about the concepts at a high level in the last video, but I just wanted to show you like a concrete, for those who haven't used Delta Lake, of how it's actually used. I used Spark in that example. I do have some GitHub repos I can share in the notes where you can interact with it with Python or Rust. There's obviously a lot of tooling being built around Delta Lake. It's become integrated into things like Arrow, PyArrow, Apache Arrow is what I meant to say, DuckDB, all sorts of different tooling is able to connect into Delta Lake, because remember, it's just Parquet files in the back end with a sort of file API on top, transaction log. But I think that gives you maybe a sense of, especially people who've worked around databases, of like, wow, you can create statements, DDL, you can run an update statement, you can insert data, but yet it's not Postgres. So it's massively scalable. I've seen Delta tables with hundreds of terabytes of data in them. which would be very difficult to do in something like Postgres. But Delta Lake's power really comes from the way it gives easy access and simplicity of data modeling at scale. It's kind of the next step forward from the data lake, where you just had Parquet's files sitting there, and if you needed to run an update statement or change a bunch of data, it basically means you were going to have to read all that data, make the change, and write it all out again. Where Delta Lake really simplifies that. It really takes away all the complexity and lets data engineers worry about data models and things like that. So maybe in the future we can do some more Delta Lake in depth, get into partitioning, things like that, and really get under the hood of it. But hopefully that gives you an idea of what Delta Lake is like.